o'clock here in Alameda, California. So let's go ahead and get started. I want to thank all of you for blocking out some time in your busy schedules to be here with me, especially on this holiday weekend. Right. Sorry about that. Let's go ahead and get started. Today we're talking about the essentials of Wi-Fi data acquisition. Let's go ahead and take a look at our agenda for today. We'll be talking about what Wi-Fi data acquisition is and how it differs from both a wired DAQ system and other wireless DAQ methods. We'll get into the specific advantages of Wi-Fi for industrial DAQ systems. Then we'll look at an application example using our new Wi-Fi stack light monitoring module. Next, we'll get into product specs, and finally, we'll wrap up the call with our Q&A session. I have Robert on the call with me today. He's one of our application engineers, and he will be available to you at the end of the presentation to answer any of your more technical questions. I do ask that you hold your questions until the end of the presentation, but if you think of a question during the show, feel free to type it into the Q&A box in your Zoom interface. Make sure it goes into the Q&A box and not the chat box. If it's in the chat box, we won't answer it. Otherwise, you can hold your questions until the end and ask them over the air if you have a microphone by raising your hand. First, a little bit about us, if this is your first time joining us. ICPDAS was founded in 1993. Our headquarters is located in Hsinchu, Taiwan. ICPDAS USA was launched in 2001 to support the North and South American markets. All of our products are manufactured in our own factory in Taiwan, where we have over 100 R&D engineers working to develop new products and support our old ones. We work closely with our customers and include their needs and input when it comes time to develop new products. We're ISO 9001 certified in the US, SGS certified in the UK, and all of our products are RoHS compliant, meaning they're lead-free. We're also a Windows embedded partner. So let's quickly look at some of the different wireless standards that you can use in the industrial sphere. So ICPDAS USA offers multiple options for wireless data acquisition and industrial communication. We have products that use 2G and 3G cellular networks, Zigbee wireless products, 900 megahertz wireless RF, infrared, and even Bluetooth. We talk a lot about our Zigbee and cellular products, so today I want to focus on our Wi-Fi data acquisition modules. We'll be focusing on the DAQ modules today and looking at one of our industrial Wi-Fi converters, but one of the advantages of Wi-Fi is that you don't need a bespoke converter or gateway. You can use an off-the-shelf router. And we'll be looking at some of those products and talking about their specs a little bit later. But first, when we say Wi-Fi, it's important to specify what exactly we're talking about. Wi-Fi refers to the IEEE 802.11 set of local area network standards. Wi-Fi operates over the 2.4 GHz and 5 GHz bandwidth. Most of the modules we'll be discussing today operate over just the 2.4 GHz band. Specifically, the majority of our Wi-Fi products comply with the IEEE 802.11b and G standards. The newest of our Wi-Fi modules comply with the IEEE 802.11n standard as well. The B and G are older specifications, but they are just right for our purposes, where very high bandwidth would be unnecessary. We're not streaming video or downloading games. After all, we just need to reliably send small packets of data at the appropriate intervals. So let's talk about some of the advantages of data acquisition over Wi Fi. The chief advantage of Wi Fi for both building and industrial automation is that Wi Fi is ubiquitous almost anywhere you can find people. Homes, offices, even factories will have an IT Wi Fi network if they're not already employing wireless on the operational side. So it can be easy to slot in a Wi Fi DAQ module where it might not be expected. This is a great way to augment your automation system with an ad hoc network of Wi Fi modules and sensors. You can put wireless modules in hard to reach places or in places where more wiring would be hazardous or impractical. Anywhere you have power and a Wi-Fi signal, you can stick a Wi-Fi module. You don't need a specialized access point or gateway to communicate with the Wi-Fi module, and you don't need specialized software to communicate with them if you already have SCADA or data logging controllers. Our Wi-Fi I/O modules all communicate with Modbus TCP, so you just need your PC or a control system to act as a Modbus TCP controller. Now, the advantage of Wi-Fi specifically over the other wireless standards, which include Zigbee and Bluetooth, besides its ubiquity, is that it is flexible and easy to use. Zigbee, for instance, is very useful for data acquisition, but it requires specialized gateways or access points to set up the network, and then you have to be diligent when designing your mesh network to ensure full coverage. Wi-Fi makes it easier to add and remove modules on an ad hoc basis while things are underway. Bluetooth modules have the advantage of consuming very little power, but they have a very short transmission distance and usually require a Bluetooth peripheral if you want to use them. Wi-Fi has the advantage of a 50-meter line-of-sight transmission range without needing a repeater, and you can couple your I/O modules with any device that supports Wi-Fi. So you get a longer range than Bluetooth, but it's easier to set up and use than Zigbee. Plus, you get the highest bandwidth of these three wireless options. Okay, so I'm hoping the benefits of Wi-Fi data acquisition are making sense, but let's look at an application example. So this is an industrial stack light monitoring system. This example is using two of our newest products, the SLP-6R1-WF and the SLPA-6R1-WF. These are our Wi-Fi stack light monitoring modules. The first, the P6, is for DC-powered stack lights, and the second, the PA6, is for AC-powered stack lights. Otherwise, they're the same module. Both provide 6 channels digital input and 1 relay output. They have Wi-Fi, Ethernet, and RS-485 interfaces. In this example, they are the first part of a machine status monitoring system. The purpose of a machine status monitoring system is to reduce downtime and production waste. The easiest way to achieve this is by installing one of our stack light monitoring modules. They monitor the output of the machine's indicators without affecting the operation of the equipment, thereby enabling the current operation stage of the machine to be broadcast and ensuring timely and accurate reporting of machine status. Without having to keep human eyes on the production floor at all times, you can minimize downtime and production waste. The module can be used to detect the status of each color segment of the stack light as being either off, on, or flashing. In addition to detecting the status of each individual color segment, the status of the combination of multiple color segments can also be defined, including the ability to report the duration of the previous and current status. This gives you an automatic way to log and evaluate machine status over time so you can maximize productivity without the need for a lot of special infrastructure. These modules make it easy to implement the stack light status monitoring via SCADA, and thus improving machine utilization and throughput. And you can see in the diagram that the stack-light monitoring modules are communicating wirelessly with the Wi-Fi access point, which is communicating over Ethernet with the control room. It's also communicating over Ethernet with one of our ICANN series industrial LED displays, and you can use that to show machine status on your various machines. Okay, so now that we know a little bit about the benefits, and you have seen how Wi-Fi DAQ can work in action, let's look at some of our specific products. The first one that I want to show you is the WF 2015. This is an RTD input module. The WF 2015 is a Wi-Fi interface that provides 6 channels of RTD input for long-distance temperature measurement, and it features automatic compensation for 3-wire RTD sensors, meaning that accurate measurements can be obtained regardless of the length of the wires. The WF 2015 makes it easy to incorporate wireless connectivity into monitoring and control systems. It also supports Modbus TCP and UDP protocols. It supports network encryption, which makes it perfect to integrate to SCADA software, offering a safe and easy access for users, both local and remote. So some quick benefits. Again, this is the 6-channel RTD input module designed for long-length sensor wires. You can configure each channel individually. This module is compatible with the IEEE 802.11b and G standards. It supports WEP, WPA, and WPA2 wireless encryption. Again, it supports both Modbus TCP and UDP protocols. It also provides 3000-volt DC intramodule isolation. And the next module that I want to look at is the WF 2026 multifunction I/O module. So again, this is a Wi-Fi interface that provides 5 analog input channels, 2 analog output channels, 2 digital input channels, and 3 digital output channels. It provides you a programmable input range on all analog inputs and on all analog outputs. That's a jumper select to change between current or voltage on both the input and output. Let's see. This one also supports Modbus TCP and Modbus UDP, along with the individual channel configuration, the jumper select on your analog input and output channels. Again, it supports WEP, WPA, and WPA2 wireless encryption, supports a DHCP network configuration, and also provides overload and short circuit protection on its digital outputs, as well as plus or minus 4 kilovolt contact ESD protection. And the next I/O module that I want to show you is the SLP and the SLPA-6R1. These are the stack-light monitoring modules that I showed you before, but I just want to quickly look at some of the specs. So the salient feature here is status monitoring for user-defined combinations of color segments. I will also report the status and duration of your machines for both the current status and the previous status. This supports Modbus RTU, Modbus TCP, and MQTT protocols. MQTT would be very useful for the stacklight monitoring solution that we saw before, where you're broadcasting the machine status to the ICANN LED display, so anyone on the production floor can see the current status of every machine as it's operating. Right, similar features to the other WF modules, though. Supports encryption, DHCP network configuration. Besides the 6-channel stack light monitoring input, this provides one relay output channel in case you have a machine failure and you need to set off an alarm or a light. And then finally, I want to look at our Wi-Fi bridge. This is the WF2572. And this device only needs to connect an Ethernet cable to the WF2572 to create an IEEE 802.11 A, B, or G wireless personal network. The interface between Ethernet and Wi-Fi uses transparent transmission so that it can convert Wi-Fi to wire internet without complex settings. The WF2572 also supports dual bands, that's 2.4 and 5 gigahertz. This supports network encryption on the access end. Again, this is a plug-and-play module, very easy to use. And of course, the advantage of Wi-Fi data acquisition is that you don't need a specialized access point, but this is a ruggedized industrial version. All right, after looking at some of the modules we have for sale, talking about how they can be applied, I hope the advantages of Wi-Fi for data acquisition and the advantages of our data acquisition modules are a little more clear. Wi-Fi is the perfect platform for adding an ad hoc sensor network onto any existing system, or for incorporating data acquisition into a residential or office setting where you can't implement a traditional wired DAQ network. Wi-Fi offers you flexibility, ease of use, and improved range compared to Bluetooth, and without any added expense or complications of using a cellular network. Wi-Fi lets you use almost any Wi-Fi-enabled PC or laptop as a Modbus controller, provided you have access to some of the appropriate software, without additional gateways or converters. And as always, why should you choose ICPDAS USA? ICPDAS USA has provided high-quality, reliable components to our customers at a very competitive price for over 20 years. All of our parts work well with third-party systems and components, and we have a very wide selection of products designed to fit the gaps in your system architecture or to form the basis of your brand new automation and control system. And that brings us to the end of the presentation. Thank you again for joining me. Now we're going to be joined by my colleague Robert. He's one of our application engineers for the Q&A session. So I'm going to turn the floor over to you, the audience. And first, we'll get to the questions inside the Q&A box.